It's a platform for consuming, designing, testing, and collaborating on APIs. I work in the Flows team, and Flows is a sort of a visual tool for orchestrating requests, workflows, the computations you might do, and the results of those requests. I live in the Hudson Valley, about 30 miles north of here, so from a New Yorker's perspective, I also come from Canada. It's been a long way. So really briefly, two features that I've worked on at Postman in the last few months that kind of underlie what I'm going to show you here today are Flows Actions, which is sort of basically a way for you to take one of those visual orchestrations and expose it as an API that itself can respond to HTTP requests. And another is the ability to actually have those act as MCP servers. And so what I'm going to demo today are three kind of small use cases. They're really toy workflows. They're not meant to be put into production tomorrow, but they're sort of explorations on, I guess, what I think is, the overarching, the characteristic pain point of doing ops work, which is that you have to compose a lot of different pieces of software to do your job. And typically that's not trivial. Like, you have to do some sort of transformation from the output you get from one tool to feed it into another. You have to make decisions that are complicated based on that output, decide how you want to shape the input that you pass to something else. And I think that, the value here, the thing that can change in the face of, tools like Flows and tools like LLMs and MCP servers, is that difficult part, doing that composition, doing those transformations. If you have tools that can sort of make the composition part fast and easy, that can really change the nature of doing ops work in general. So yeah, I'm hoping I'll sort of, if not prove that thesis today, at least sort of demonstrate the directions we might want to go in. So yeah, here are the three workflows. First one concerns GitHub Actions. We're going to get a workflow status, restart a workflow because it keeps failing, and then raise an issue. So let's get into that. So yeah, I've got a repo here that I built. And it's a NixOS configuration for a droplet that I have running in DigitalOcean. I'll get more into the NixOS part of this later. Real quick, it just describes system, a Linux system, all the software that's installed of it. It's sort of like a package manager and system state description all at once. When I actually make a change to this configuration, I want to run a workflow that checks that my definition is syntactically correct, that it references everything that actually exists, so on and so forth. So I have to find one, but it seems to be failing for some reason. So what I want to do for this repo is make some tools that allow me to both monitor and potentially update the status of this repo. And so that's what I've done with this flow here. I won't get too in depth on sort of what's going on, but just know that I can basically have a request that initiates the computations that this flow does, and then do pretty standard computations over it, like selecting the value of one of the fields in the JSON body that I get. Depending on that, I take different actions. So one of the tools that I've exposed here is called GitHub Last Workflow Run. And real quick, the way that I actually sort of expose this tool definition to an agent like Claude is via this scenario. And I want to be clear, the UX here, this is a very new feature, and UX will reflect that. What we wanted to do is make sure that people were able to actually build with this and sort of see what they did with it. So that way we could really make sure that we're making a UX that suits how people use the tool. But for now, this is how I supply the tool definition for all the tools that I expose in my flow. Yeah, sure. So yeah, I have this tool defined and it's exposed on the public internet, and I have Claude set up with all my tool definitions. So what I want to do, and I have been conservative recently about telling it explicitly to use tools because sometimes it is very eager to just do the job on its own. And these are all the tool that I've defined takes the branch and the repo as an argument. So it's going to go and it's going to use my tool that I've defined that actually orchestrates the GitHub API requests. Yeah, sorry about that. So yeah, it gets back the results. And this is something that I've defined here in my flow. And it's just a record with for the most recent workflow, gives you the ID, the name of that workflow, and the status. So it failed. What do I want to do? I'd have another tool that can do things like restart workflows. So I say, goes, asks me for verification. Yeah. So it restarted it. Let's see what's going on. That failed again. Unsurprising. Yep. Now, whenever I ask it for a joke, I feel like it needs a lot of work in that regard, but it's great at calling tools. So yeah, it keeps failing. I want to raise an issue. That's another tool that I've defined in my flow. And yeah, it went and created the issue, created a nice title, and a very solid body for this issue. So, aside from the specifics of the tools that I've created, I think what's refreshing about, workflow like this is that the context of what we're doing propagates through. I've sort of gone through, I've asked Claude to check on the status of workflow, asked it to restart, and now, it remembers everything that it's done. And so when I say create an issue, I don't have to propagate all that context, all that knowledge that I've gained, trying to work through this process myself. I can very easily have that be done automatically too. And so I think, the fluidity there is something that current tools, a lot of that are things that we have to keep track of, do ourselves. And for my part, I think our effort is better spent on actually doing the specific automations for each of these tasks rather than, the orchestration and the munging that we have to do to get them to all work together. So yeah, that's that workflow. Proceed to the next. This one is a small little demo doing container orchestration. So I have on DigitalOcean app platform, just a little 3 containers. They're all just running an Echo server. So now, just want to ask Claude, let's see what the average CPU utilization is. And once again, that's a separate flow that I've created that handles these tool cases. I've been grouping all these tools together thematically, and then it branches on the tool name. You could define one for each tool that you use, potentially. Really depends on your taste, but I find this an easy way to group logic. So. I provided the name, which I've defined as an argument, and the app component. It's going to go, and it's once again going to consult my flow that I've defined as a tool. And yeah, gives me a pretty low number, so I think I probably don't need 3 separate instances running. Let me tell it to scale down. I'm going to tell it to scale down to 3 instances, and it's going to do what I say because, as was pointed out earlier, LLMs don't really have morals or a full picture of, the context in which I'm working in. So yeah, the way that I created my flow was that I had it fetch the current number of instances, Sorry, I need to zoom in again. No. And, really briefly, I fetch the current number of instances, and if in fact the number of instances is not less than the number that I'm trying to scale down to, I return a 400 and, say that's, not actually possible. So I've learned that. And yeah, that time it worked. And, the sort of the small takeaways from this example, I think, are that, LLMs are non-deterministic. And you can imagine that being kind of scary when you're talking about mutating infrastructure. And so I think, a good way to, when we start merging these types of tools together, is to handle the safeguards in a very deterministic way so that they're very auditable and you can be very sure that what's going on isn't going to be dangerous or disruptive. But that said, that way we can still benefit from sort of the intuitive composition that we get between all the separate tasks that we have defined in a more deterministic way. So now I'll move on to the last demo. And this is, I have a VPS that's running NixOS. If you're not familiar with NixOS, it's a Linux distribution mentioned earlier. And basically it comes with a tool, Nix, which is a programming language and a package manager. And it lets you define a system in a completely declarative and immutable way. So, there's no more like sort of, oh, what did I change in this configuration file that I haven't kept track of? Basically, everything is defined with this language that's great at creating, in a functional declarative way, these configuration trees, merging them, updating them as appropriate. It's a great way to manage a system, especially at scale. But it's sort of, really renowned for being obtuse in a lot of ways. Documentation, the Nix language itself, the output from error messages. So, it's another case where having something like an LLM that can sort of use its vast breadth of encoded knowledge to tell me what's going on when I'm having a hard time either finding it in the documentation or deciphering from error messages is super useful. So one thing that you can do is that, when I update my configuration for my NixOS system, I find myself wanting to know which packages are getting updated, what versions are changing. There's a tool when you do that called NVD that gives you sort of a nice breakdown on the command line. And so what I've done here is basically just made a small little toy web server. Just little web server with Rust and Axiom, and it goes through, it runs some command line tools to get a list of which packages, when I have my new configuration that I'm considering applying versus my running configuration, I can get a diff of which packages will be added, which packages will be removed, which will have their versions updated. And this web server just returns, nice little JSON summary of that. Show you what that looks like. That takes a little bit, but yeah, so I've just configured it to send me back, here are the things that are getting added, package names, here are the things that are getting removed from versions and to versions. And the thing is that I often notice, when I update the state of a system is that, a modern Linux installation has a lot of packages. There are ones that I've explicitly installed that I know about, but there are its dependencies. And frankly, I don't always know what each of those are. But if I want to be a responsible system administrator, I kind of want to know what some of them are sometimes to make sure that nothing, that I don't know about is happening to the extent that's possible. So, even though this output is helpful, I might actually want kind of more info. And again, that's a place where an LLM can come in very handy. So, and then once again, for the last time, I've defined a flow here. This one's very simple. All it does is just run that request. And then, the point here is just to wrap it, sort of the tool protocol trappings. So, yeah, I'm going to ask it. Define the host name as an argument. And I'm going to tell it not to look it up on the internet, just use what it knows. And it's going to consult my flow. It's going to think for a little bit. Yeah, now, I can use this tool and get some useful output. Then I can also use the LLM to add a lot of rich context to that output. And, again, sort of the application to ops work here is that when we've got a lot of tools, there are a lot of things to keep track of. And, some of that cognitive load is, I have to keep some of these things in my working memory to do my job. I don't have to keep all of them in my working memory. And in fact, I can't. And so now having the ability to do this sort of work and have the context added in a very intuitive and straightforward manner is really invaluable. And also what I want to stress is that, here I'm not using an LLM to avoid having to gain knowledge. I'm using it as a tool to actually help me build knowledge easily and more quickly. So yeah, those were sort of the 3 toy examples. And, how do they sort of, I'll get to that in a second. So, we saw like a very conversational approach to determining system status, making config changes. Existing DevOps tooling is really powerful because it needs to be. But the problem is that, that necessarily comes with a lot of tools, a lot of dials to turn, more than we can keep in our working memory. And so, I think the question here is, does this workflow, if it ends up becoming how we work, does it mean that we don't need to know our tools? Does it mean that the dev part of DevOps goes away? And, I think the answers are no and no. Repeatable automation via software has always been the goal of DevOps. And, what we're doing here is still doing that, with software, automating the steps. And what we're offloading is that composition. The part that's always been kind of tedious, takes a long time for, what feels like more time than it needs to take, given how ultimately conceptually trivial the work is. If you think about the workflows that we do in DevOps, they're often like pretty hairy, directed graphs. The subgraphs represent different tasks that we do. Often they don't even need to happen in every workflow. Sometimes they happen in different orders. And these, the human brain is really good at sort of implicitly constructing those workflows and actually executing them in an really intuitive way. But they tend to be kind of difficult or at least tedious to describe in software. And so, now we have an opportunity to use a tool that's really good at that, taking our sort of intuitive understandings of workflow and turning it into a software process. So, I hope what I've demonstrated is that in a realm where, we sort of desperately need to compose so many different things and need to do transformations between steps, that's sort of the benefit, and that's the direction to go in terms of automating our work even further. And then, lastly, on a personal note, I feel like my bugbear as a software engineer, a software user, has always been that it is difficult to compose software. And it's not because there's some physical rule that it needs to be difficult. It's always just the design decision that leads to that being impossible. I don't know if anyone here has ever been nerd swiped by BOS. It's an operating system that existed in the early 90s. Apple almost bought it. It could have been sort of the basis for macOS instead of Next, but didn't work out because they were asking for too much money. But it had a lot of really rich facilities for allowing software to interoperate. It sort of had a plug-in architecture for converting between file formats. It had a sort of a subscription system for applications that could say, hey, I'm able to consume this sort of media, or hey, I'm able to produce it. It had reusable components for actually, displaying media in different applications. It's sort of this really easy way to do a lot of things that, again, are complicated and this operating systems that we have now, but they're not complicated because they have to be. It's just they're complicated because that's how things have been defined. Yep. So yeah, real quick, I think having that sort of interoperability, turns out to be a coordination problem, and one that probably isn't solvable, so long as we have free will. So, in my opinion, I think we got to the solution of that problem in a very different way, and that solution looks like LLMs and tool usage. So I'm excited to see what we do with it. Please.